Well, hello and welcome YouTube, Mr. Robinson back here with, I guess a brand new exciting video, if you will. Hey, it's an honor and privilege to be serving you here today. This is every day here in my virtual classroom. Step on aside if you're daring to do so. This is from sections 11.5 and 11.6 in the Big Ideas Math Integrated Math 2 textbook. There's a specific problem number in each section, and it was specifically number 24 in each of them. They had this item called a FRUSTUM. And I'll show you what the page things were, and when I did the solution guide things with them, I saved work on them. Now, each problem's answer, I believe, I actually got incorrect. And the whole goal of a solution guide really is to talk you through some stuff. I want to teach you some things. But it's also probably to get the problems right. And I was well aware that I got it wrong. Something felt wrong about it, the way that it appeared. Sometimes that you feel like they're supposed to give you a pattern of something that's supposed to happen. They kind of felt right. They were very close. What I got was very close. But I couldn't figure out the first one when I was talking through it. And then I even said in my 11.6 video, the next morning I did it like cake, just as I did it there. And I want to attempt to just redo them, basically get them correct and address two of the errors with you. So these were problem number 24 in each of sections 11.5 on volumes of pyramids and 11.6 surface areas and volumes of cones. So if you didn't do number 24, this video is probably not for you. It's a little more the enriching things. They literally call it thought-provoking in the section. I'm looking at it right now. It's that thought-provoking set. And this was the solution I went through on number 24 right here. And if this looks like your alley and your thing, go for it. But this was number 24 in thought-provoking, a frustum of a pyramid, blah, blah, blah. And then on the next one was number 24 from section 11.6 on cones. And then this was my work for that one right here. So you can see that there's quite a bit of work. And literally everything I did was pretty much to the point. Fine. But if you want me to walk through it again and kind of do it, what I did on the cones part was, I think, more appropriate with regard to the X thing that I did. So I'm going to do that again, this time on the pyramid thing. I think that's how I did it on the whiteboard at the time. My two mistakes, my one mistake on this one here was, and I can't process it with the way that I wrote it. I can't remember how I started saying this out loud. But I think this thing was supposed to have a B right here in some way. Not that I intentionally was supposed to, not that I said, oh, I'm going to leave out this B, but somehow a B was supposed to be in here. And if a B was in here, then it would have allowed later, when I get to this portion, a squared times B times H and B cubed. And then it would have gotten everything that I needed from there. Literally, that was it. I needed that B there. Everything else would have been addressed. On the second one right here, my problem was actually a carryover from one step to the next. You can see here that I have AB squareds here and here. And then in the next step, I wrote this AB squared as an A squared B right there. It should have said AB squared. It should have said AB squared. And then they would have canceled out instead of been separate terms. And literally that was it. It was just an incorrect carryover. The other thing that I did here, it wasn't wrong, but I don't want to do again because people probably would have been confused, was from this step to this step, I switched B minus A to A minus B by changing all the signs up top. So I'd rather turn it into A minus B to begin with. So I'd probably rather just redo that problem as well. So we'll redo both of them. I'll go ahead and keep the diagrams that I had from before and just make them happen again. So without further ado, guys, I'm going to go ahead and try and redo these problems for you, with you, all that kind of stuff. Let me see if I can get everything kind of restored. I'll try and copy and paste this thing over and delete any of the parts that that I won't use again. Okay. So, and I was trying to do this 1:4 ratio stuff. Let me get rid of all that. Oh, that was figure 1 and figure 2. I can do that again. But okay, so this is kind of my drawing for this thing here to begin things. Number 24, they're both number 24. This is the one from section 11.5. You can see in the problem set where it says what page it is. A frustum of a pyramid is the part of a pyramid that lies between the base of and a plane parallel to the base as shown. So this guy down here is the frustum. Write a formula for the volume of the frustum of a square pyramid in terms of A, B, and H. Consider the missing top of the pyramid and use similar triangles. So the green part that's filled in is the frustum. What we can do here, and they say similar triangles. I'm going to go more similar pyramids, and that's kind of what I did last time. What I did was I connect this all to make a pyramid. So now we kind of have two objects we want to look at. There's this one here, and there's this one here. And if I take the purple, the entire pyramid, and subtract the green pyramid from it, then I'll get the frustum's volume. And both these pyramids are similar. They're literally, one's just an extension of the other. It goes further down, and there's a corresponding aspect ratio there. Now, the way I struggled last time with it was trying to introduce a new variable, saying, I don't know if I'm allowed to do that. And when I did it in my classroom, it felt like it was the only natural thing I should have done, and it totally worked out. So I introduced a new variable here, and I call it x. This is the height of the smaller pyramid, x. Now, x won't be in my final answer. It's not supposed to be. It's not allowed to be, but it won't be. I'm going to be taking it out. I'm going to be putting x in terms of the other letters, and I'm going to substitute. So it's going to be fine. If that's x, then the entire length of this thing here is x plus h. So keep that in mind. This entire height right there is x plus h. I'm going to get rid of that, but I want to make sure that you're aware of that. So these triangles are similar, which means there's a corresponding side length of proportionality. These are squares here, and so B's edge length corresponds with A's edge length in such a way that X's height corresponds with X plus H's height. So I can say something like this. From the small triangle B to the large pyramid to the large pyramid A, I can divide those side lengths just like I can divide the height of the small pyramid with the height of the large pyramid. Now my goal in this scenario is to get x by itself, solve for it, so that I have something in terms of a, b, and h. So when I calculate the volume of this pyramid, in this pyramid with 1/3 area base times height and 1/3 area base times height that have x in it, I can plug something in for x. And the the cone one is going to be the exact same thing. It's going to be the exact same thing. So let's cross multiply. I get b times x plus h equals a times x, like so. And then bx times bh, or plus bh, excuse me, equals a times x. Now I'd like to get x by itself, and I'd like to make sure it says a minus b ultimately, so I'm going to subtract bx from both sides. So it'll look like that. B times h equals ax minus bx, and x is a common factor to have a minus b. And I divide both sides by a minus b, and you'll get x equals b times h over a minus b. So if you remember from that other thing, I'm just boxing it to kind of, that's not the answer, but I'm going to box this thing to kind of get to that phase one here. I have now this height in terms of h, a, b, and h. So I can use that to substitute later. I'll do it later though, because x is just ordered right. But you'll notice the thing that was missing for me was that b. Now I was trying to reason with it in a different way. I must have messed something up, but I didn't have a b in there. So now I do. Now there's an object 1 and an object 2 we're going to go with. Object 1 is the small guy. Object 2 is the whole larger pyramid. And when I subtract volume 2 from volume 1 minus volume 2, whatever. Volume 2 minus volume 1, I'll get the volume of the FRUSTUM. So volume 1, the smaller pyramid, has volume of object 1 is 1/3 area of base, that's b squared, times height. Now this height is x. So this is the volume of the smaller pyramid. The volume of the larger pyramid is 1/3 area of base times height. Now this height is x plus h. It's got the x, it's got the h right there. Now there's still an x involved. If I want to simplify this a little bit by, I'm going to distribute the a squared. What you end up finding out is here, the 1/3 ends up being a common factor with everything. So I really want to leave that 1/3 out of anything that I do. But I'd love to distribute the a squared into these as a whole, because ultimately you're going to have all these different sets of terms which won't share common factors, and they probably have to do something else together later. So I'd love to distribute that, and in all honesty, you'd like to treat the b squared x as its own thing right here as well. So when I want to find the volume of the total, and after I write total here this time, after that I'll just write v, we're going to take the volume of the bigger guy minus the volume of the smaller guy, which means we got to do 1/3 of, and this is where 1/3 is a common factor, here and here. You're going to hear all the same things for the volume of a cone, by the way, except there'll be pi in it. A squared x plus a squared h minus b squared x. Now this looks a little uneven right now, but don't forget that x has a whole thing to it. B times h over a minus b. And this is a great time to go ahead and throw that in. So the volume of that total, 1/3 is still on the outside. And now when I substitute for x here, I will get bh over a minus b for the first term. This is a squared h. There's no x in there, but you're going to see we're going to want a common denominator later. And then b squared here is going to multiply by b times h over a minus b. Now let's attack a common denominator. I'd love to get this a squared h over 1 here to get a whole a minus b over a minus b going, which also means that I have to distribute a squared h into both of these. And that 1/3 still stays factored out. Pretty soon what you're going to see, unless you can see it right now, y'all, there is an h that exists in every single quantity here. So I could also factor an h out of here as well. So let's do that. 1/3 h is gone from each of these. And now on the inside, you're left with a squared times b as that first term. A squared will distribute into a and become a cubed. A squared will distribute into negative b and become negative a squared b. And then b squared times b is b cubed. This is all over a minus b because we now have a common denominator. As far as how do I say it? Well, one thing for sure, a squared b minus a squared b is 0. Those cancel out. And now you're left with something that says a cubed plus b cubed. I feel like that's supposed to say a minus there. Let's see. This was minus, this is supposed to say a minus. I almost messed up again. So that's a minus there. So this should be a minus. Otherwise, a minus b can't cancel on bottom later. So now v is 1/3 times h, and I have a cubed minus b cubed on top, and I have a minus b on bottom. Now, nothing can cancel out right yet. It's not like I can cancel the a's or a minus b's, not until this thing can factor out. And a difference of 2 cubes, this is something that, I'll be honest, when I stated out loud what the factorization of this was last time, you wouldn't know in IM2. So this is a part where I don't know if I'm doing this differently than, say, the textbook would have expected me to. I have no idea when they wrote this problem, but it's unlikely that you're factoring a difference of 2 cubes at this stage. If you know how to, difference of 2 cubes like this factors into a minus b times a squared plus ab plus b squared. There's nothing else to it that I can state for you to totally understand. You also probably haven't done long or synthetic division to come up with this. So it's something that I know how to do. It's something that's a very challenging problem. I'm sure there's more than one way to do this, and I'm sure I'm not doing it the best way. But the a minus b's now with a common factor can cancel and divide. So ultimately, your final result simplified is, or as you know, with the factorization, is 1/3 times the height times a squared plus ab plus b squared. Which, that's the volume of the frustum. You know what I should be putting instead of total? Let's put v sub f. Instead of v sub total, it's v sub f, 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 v sub f. And that looks like the answer that I want. This looks like there's some symmetry aspects to it, and that makes sense being squared prisms. I felt like I was getting near there when I was doing the cone one at the time. I just didn't cancel something out. Something else cleaned up in its own way, but it didn't seem like the one I got on the whiteboard earlier that morning. And this is kind of what I feel it's supposed to be, and that looks like that would be the answer. Because I was missing that b and the other thing once I had that. So there's that one. That's the volume of this frustum right here by subtracting the volumes out from those. I'll do the cone one, and honestly, guys, it's going to sound like a repeat of what I just did in a lot of different ways. Difference is, volume of a cone is pi r squared instead of just the r squared. So honestly, you're going to see a lot of similar things. It's just going to look like, okay, you're doing the same thing over again. Well, I kind of am. So here was the, well, I already got rid of the original work of the other, but here is the other problem. This time A's on top, B's on bottom. I think that's what made me change the way that I went about it. I'll try and make it say A minus B as to not confuse you for that thing, so it'll look slightly altered just because of that. But let's copy and paste the one that I made at the time, which was this one. I'll go ahead and still use this information. There's nothing wrong with what I had. In fact, there's nothing wrong with the majority of what I have here, except I want to instead subtract the other way. So I'm going to copy and paste that much, and I'll navigate through exactly what I'm saying that I'm going to do here. So frustum of a cone is the part of the cone that lies between the base parallel and a plane parallel to the base as shown. Write a formula for the volume of the frustum of a cone in terms of A, B, and H. So same thing, I extended this frustum upward into a cone here. So I have a cone 1, object 1, and then I have object 2, which is basically the rest of it. I don't know if this was supposed to be labeled somehow. I'll just give a little 2 right there to indicate the arrow for it's the entire big cone. Object 2 minus object 1 would give me the volume of the entire thing. Of the frustum, I should say. So I have the same setup here. Check this out. A is in the small pyramid, cone. A is in the small cone as the radius. B is a corresponding part in the larger cone. X is the height of the smaller cone that I'm establishing there. And X plus H is the height of the larger cone. Now when we cross multiply, A times X plus A times H is here, and BX is here. I would love to make this say A minus B again, just to have that kind of alphabeticalness to it. But if I subtract BX over, I subtract AH over here. And that's kind of what threw me off last time. I wanted to keep other things positive. So we'll see what comes as a result of this. I haven't tried it yet, but I guess when you substitute things in, the signs will change in the substitution, which is fine. X is a common factor here. You're left with A minus B. And you get negative AH, and then you divide by A minus B, you get negative AH over A minus B. So this is what I'm going to use instead, the other way that I had it here. And with that substitution, we'll go ahead and write out the volume of object 1, the volume of object 2, and do the subtraction. So the volume of object 1 of this cone, the smaller cone, is 1/3 area of base, that's pi times r radius squared, 1/3 area of base, pi times radius squared, times the height, which is x, which I will not yet substitute. I shall momentarily. The volume of object 2 is 1/3 pi times the radius, b squared, times the height of the overall cone, x plus h. There's the h, there's the x, and that's the overall cone's height. I'll once again do the distribution that I did before, as well as any common factor such and such, which, you know what, if you want me to substitute the x stuff right now, I'll go ahead and do that. It's not so much more rewriting, and I want h to be a part of the common factor stuff. So let's just do that now while we're kind of getting the idea of what else will be common factor biz. A squared times, this is going to multiply by negative AH over A minus B. And this one here is going to look like, ooh, I still got to distribute B squared. Hold on. Let me clean up volume 1 first, then I'll go back to volume 2 one more time. Let's get this kind of lower and waiting in the wings. So this here, negative, whoa. Give me a second. Something just entered my throat. Okay, I don't know what that was. That was kind of weird. All right. I don't know if the negative... Listen, I'm going to factor out the 1/3 pi for now. I think even the h will belong out of the factorization momentarily, but let's leave the negative on the inside, because when I do the subtraction with the stuff on the inside, because this one won't have a negative, so there's no negative to factor out of this one, and they're going to share a common factor of 1/3 pi. Even the h will factor out later, but eventually I'm going to subtract volume 1 anyway, so subtracting the negative will become addition. Now, a squared is going to multiply with a, and I get a cubed. There's still an h there, and I still on the bottom have a minus b. So here's a different version of writing volume 1 that I'm going to be using in a moment. Now, when I do the subtraction, keep in mind, this one will also have a 1/3 pi factored out. You can almost imagine that it's factored out right now, which is good. But I want to distribute the b squared into here. I also want to turn x into a times h, negative a times h over a minus b. I'm watching War for the... Sorry. One of my friends is saying, I'm watching War for the Planet of the Apes and blah, blah, blah. The new movies kind of coming out here. All right. So when you distribute the b into there, b squared, I should say, let me write the b squared h first, because I know that this one's going to turn negative. Remember, this is negative, x is negative ah over a minus b. So that'll be a negative a, I'm going to put the b squared here as well, h over a minus b. So I guess this isn't exactly like the other one, although most of the stuff in the ultimate result will be. So now I can do the subtraction. The volume of the frustum is going to be the volume of 2 minus volume of 1. And keep in mind, they both have a 1/3 pi as a common factor. It's at this stage, though, that I think I can even factor that h out. Notice now they all share an h. H can pull out here and in front. Here, h can pull out here and in front, and with the common factor here, this h can pull out here and in front. So I'm going to put the 1/3 pi times h all out there together, if that's okay. 1/3 pi times h, and now h's will no longer exist inside of any of these things. Now, it's volume 2 minus volume 1, so I have b squared, which, by the way, needs to multiply by a minus b over a minus b to get a common denominator. Right? That's what we kind of need here, because it's just over 1 so far. And then it's minus this one, minus ab squared over a minus b. And then this one, we're going to be subtracting. Keep in mind, we're going to be subtracting volume 1, and volume 1 contains the negative. So that becomes subtracting a negative, which is addition. So we're going to add a cubed, remember the h's factor out, over a minus b. This way seems longer than how I did it the other day. So the volume of the frustum, 1/3 pi h, is on the outside. We got to distribute the b squared into all this, and we have a common denominator now, by the way. So we have a times b squared times negative b is negative b cubed. I have a minus ab squared here, and here I have a plus a cubed. This is all over a minus b. This is where stuff is going to start to look very familiar. I have ab squared minus ab squared, which will cancel out. Last time I didn't have it cancel out because I accidentally rewrote one as a squared b instead of ab squared. Now here, a cubed, positive a cubed is here, negative b cubed is here. So inside of there, I should write it as a cubed minus b cubed over a minus b. This should look so much like the last problem now. A difference of 2 cubes factors into this set, right? Oh, not pi rh, just pi h. There's no r. The radii are a and b. Pi times h times, so a cubed minus b cubed factors into a minus b times a squared plus ab plus b squared. And on the denominator, I have a minus b. And the a minus b's cancel. They divide out there. So ultimately, for the volume of this frustum, in terms of a, b, and h, you are left with 1/3 pi times the height times a squared plus ab plus b squared. And that should be the answer there. So it's very close the last time. Obviously, I did it a different way. This one kind of connected more into the way I just did the last one. What's the difference between this answer, volume of a frustum, and this answer's volume of a frustum? The pi symbol. Obviously, A and B represent different things. One's an edge length and one's a radius when it comes to it, but the volumes of those seem to match up. And that's where I felt uncomfortable with this one when I answered it in the video form, because it didn't seem to match what I got in the pyramid earlier that morning when I tried it on my own classroom whiteboard. So, guys, this was kind of a longer video with this stuff in mind, but this is just as long as the problems go when it comes to talking about it. That ought to do it for this one. This is Mr. Robinson. Thank you so much for watching, and I hope that everything else that I did leading up to those were correct. I just knew that the frustums frustrated me when it came to not getting those right answers for you guys, and I felt like it was my own little algebra mistake, so I've addressed them for you. Anyway, take care, guys. I'll see you in the next one.